Welcome back to InfinitForm. In this video, we'll walk you through optimizing your first design. While the wizard is perfect for quick results, advanced optimization puts you in control of every parameter, ensuring your design meets all your unique engineering requirements. From your cabinet, locate your project, click the three-dot menu on the right, and select Open. Your 3D model will open in a new tab ready for optimization. Now, let's prepare your design for optimization by configuring the basic parameters. Start by selecting the Material tab and browse the library to choose your component's material, whether it's aluminum, stainless steel, or titanium. If a desired material isn't in the library, you can define customized material properties. Next, go to the Design tab to define the design space. This tells InfinitForm where to focus the optimization. Auto Select will pick a body with the largest volume. Then, select the non-design spaces, areas you want to preserve. You can manually click on each component or use the Auto Select feature to speed things up. The Auto Select option will automatically select all the bodies except the design. These parameters will guide InfinitForm, ensuring the optimized design stays within practical constraints. Next, let's define the load cases to simulate real-world scenarios. Click the plus button to create a new load case and select the load type. For this example, we'll use a static load case. Each load case has two parts, boundary conditions and loads. The boundary conditions indicate how our design is constrained or fixed against movement. Loads indicate how our design acts under loading conditions. Start with boundary conditions. Click on each boundary condition to assign fixed area that will remain stable during optimization. You can select the relevant degree of freedom and/or direction on which the part is fixed. Now, apply the loads to the relevant components. This time, use Auto Select or manually choose the areas to apply forces, moments, or pressure. Finally, use Group Edit to specify the load values, such as force magnitude, pressure, or acceleration. Please check our next video, which focuses on the applications of loads in more detail. InfinitForm can handle multiple load cases simultaneously, ensuring the optimized design performs under all conditions. Now it's time to define the optimization goals and manufacturing constraints. Select Goals from the toolbar. For this example, we'll minimize weighted compliance, which means maximizing part stiffness, and set a mass target of 1.65 kilograms or 30% of the original mass. Alternatively, you may define mass minimization under stress or deformation constraints. Finally, let's optimize this design for CNC machining. Here we can define the symmetry planes, machining directions, and minimum tool diameter. In this case, we'll optimize for the Z direction with a minimum tool diameter of 2 millimeters. This step ensures your design meets performance goals and is optimized for efficient manufacturing. With everything said, it's time to optimize. Click the green play button at the bottom, and InfinitForm's GPU-accelerated engine will analyze your model, adjust geometries, and generate an optimized design. In just minutes, you'll have a design that's lighter, stronger, and ready for manufacturing, all within your specified constraints. Once the optimization is complete, review the results in the viewport. Use the view cube to inspect the model from every angle or toggle between the original and optimized designs for a side-by-side comparison. Need to make adjustments? No problem. Simply revisit the constraints, tweak the parameters, and rerun the optimization. You can also duplicate the project to run multiple iterations of the design. Congratulations! You've successfully manually optimized your first design in InfinitForm. This process gives you total control, enabling you to fine-tune every detail of your project. Stay tuned for our next video, where we'll explore advanced load case settings to fully validate your designs before production. Thanks for watching.